our rectangle 4, this is one that we haven't seen before, so let's take our time with this one. The height is going to be found by substituting in x equals 2. And when that hits the curve, so f of 2, we get a height of, well, 2 plus 1 is 3, and 3 squared is 9. So we get a height of 9. Now, we're not just after the heights, though, of all these rectangles. We obviously want the areas. So with a width of 0.5, we can take these heights and multiply them all by 0.5. So let's go back to our first rectangle. Okay, it has an area of 1.125. Second rectangle has an area of 2. Third rectangle has an area of 3.125. So all matching up with what we saw from part A. Okay, because like these rectangles have just been shifted across. But then our biggest rectangle, 0.5 for the base times the height of 9 gives us an area of 4.5. So we can take these 4 rectangles now and sum their areas to get our total area. 1.125 plus 2 plus 3.125 plus 4.5, and that gives us 10.75. And now we'll put in the square units. Okay, so out of rectangles, remember it makes sense that this is quite a lot bigger than our answer to part A, because we are now in fact overestimating the area. If we look up here, we can see the curve line still just going through here, and each of our rectangles goes above the curve, so we've overestimated. Just as a fun little extra, what would happen if we took the average of our answers to part A and part B? Well, this should give us an approximation that is even closer once again. Part A underestimated, part B overestimated, so the average should be even closer. So how do we find the average? Well, we add our values together and divide by how many there are. In this case, there's just the 2 values, and before even going to a calculator, we can hopefully see that the midpoint, or the average, between 6.75 and 10.75 is just 8.75. Now, we don't know how to do this just yet, but the true value, the true exact value of this area is 8 2/3. So that's the true exact value. So you can see that this average is actually quite close to the true value, while our 6.75 was quite a bit under, and our 10.75 that we just got in part B was quite a bit over. But we'll obviously see how to arrive at this exact true value in future videos. Alright, well, that finishes off part 1 on integration, where we've looked at approximating areas under a curve by inner and outer rectangles. Good luck with the exercise.